So good afternoon, everyone. My name is Mark Cheney. I am a principal product manager for Amazon Cloudwatch. So I've been working around containers for about 5 years now, monitoring, troubleshooting primarily around that space. Have quite a bit of experience in that space and happy to be here to be able to tell you a little bit more about what we're doing with Cloudwatch. Don't like the describe command. Sometimes it gives you too much information about something. Ultimately, by a show of hands, who uses or knows about Cloudwatch? I like that. All right, pretty much everybody. And the ones that didn't raise your hands, you probably use Cloudwatch and don't even know it. Ultimately, right, I think it's important to understand our mission around what we want to try to deliver and giving you visibility across all the applications and systems that you have in a very timely fashion. This is across all of your cloud resources, right? Any AWS services, most AWS services produce Cloudwatch metrics today, logs. All that information can be stored in Cloudwatch. We collect that information directly from services or also available through our Cloudwatch Agent. So it's a unified agent to collect both metrics and logs, brings the data together, helps you monitor, troubleshoot that data, and ultimately set alarms, right? And why is that so important? Well, ultimately, what you want to be able to do is create automation action on these alarms. Things like scaling up your auto-scaling groups or scaling it down if you're over-provisioned, or terminating an EC2 instances, or maybe just start it by restarting it to make sure that everything's working fine. And also going into the analysis part. So whether you're using our CloudWatch Logs Insights that we just recently announced at reInvent, the ability to use advanced search capability to create richer analytics around your application logs, host logs, CloudTrail logs, VPC flow logs, all type of sample queries you can use, or if you're using our SDKs or our APIs to be able to get the data out, visualize the data in other sources. These are all different ways that you can analyze the data in CloudWatch. So we offer this platform of services that, very importantly, whether you're just getting started or you need to scale to an unprecedented level, right? You're seeing here that, right, 1 quadrillion metrics. Who knows what 1 quadrillion is in terms of numbers? It's 1,000 trillion observations, right, data points that we can collect a month. So we'll scale to meet your needs. I think that's important, right? You need to be able to have that trust and that relationship with us to know that you're just getting started, we can accommodate your needs, and as you're growing, we can accommodate your needs as well. No one wants to be in this state, right? Monitoring is complex. There's a lot of moving parts, right? You got EC2 instances, you got auto-scaling groups, you got volumes that are restricted based on either the usage, right, how much space that you have in your volume, or the disk IOPS. You got network capacity based on the instance types. All these things just make things more complex to have to manage. The opportunities with containers, right, come with its own set of challenges. Having to deal with this high cardinality data, the ability to also understand what's going on with these short-lived instances, be able to understand the trends and the patterns around this data is critical for you to be much more proactive in trying to identify what problems are happening in your environment so that you can react to them much more quickly. Right-sizing your environments is also an important thing. As you're breaking down the monolith, right, creating these microservices or packaging existing Java applications or Node applications, you ultimately need to understand how your environment will grow, right? What is the demand for your compute capacity, and how do you scale accordingly to be able to accommodate the needs of these workloads? How do you detect issues more quickly to make sure that you're not violating your service SLAs? And health and performance, right? It's one thing to say that I'm going to collect everything that's out there, all the metrics, but what are the important metrics that you need to look at? What are the important metrics that you need to action on? Are most of you familiar, most customers, AWS customers, can go through their account teams to raise product feature requests. One of our leadership principles is customer obsession, right? A lot of the things that we build comes from the voice of our customer. So certainly continue to recommend that whenever you have an ask, right, work through your account team, make sure that you raise these, what we call customer influences, on top of these product feature requests, because that's how we prioritize our roadmaps. This is an example of a snapshot specifically for EKS around the need for monitoring, the need for collecting logs. So I'm very excited to announce that we have an open preview of a new product, a new service for CloudWatch called Container Insights. This is available today in not all regions, but most regions. You can see our documentation to know which regions. But ultimately, it'll give you full observability around the services that you want to monitor, help you troubleshoot these services, and alarm against any containerized applications and microservices that you have in your environment. It helps you get started very easily, deploying the technology you need to be able to collect performance metrics, the high cardinality and ephemeral data that you want to be able to collect, summarize that, create, pre-aggregate the data, and make sure that we do this in a reliable and secure way. We've also built some pre-built visualization to help you link that data. Right? It comes back to the observability concept. Right? It's not just about metrics, logs, and traces, but it's also about the state of the environment and making sure that you can carry that context through as you're troubleshooting and monitoring your environment. And most importantly, the ability to do ad hoc analytics. Right? We're not going to be able to solve everything. There's always going to be different analytics use case that you're going to want to have to drive based on the logs you're collecting, either the host logs, application logs, or the metrics, that high cardinality data that you want to create more analytics to be able to further triage and isolate problems. So there's two images, Docker images, that are available today on Docker Hub that are public right now. One of them is the Cloudwatch Agent. So the Cloudwatch Agent is how we collect all the performance data. Okay? So we leverage kubelet to be able to use cAdvisor to collect all that data, bring that data into Cloudwatch, and we use FluentD. Anybody familiar with FluentD? I think everybody uses FluentD, mostly in the Kubernetes landscape anyways. So ultimately, there was no need for us to reinvent the wheel on that one. We will support logs as well from the Cloudwatch Agent to continue to have one agent, but we wanted to create very little friction around how you can use something that is massively adopted in this space, right? So we're certifying this plugin right now, right? It's the Cloudwatch plugin, and you're able to use the Container Insight, use the FluentD plugin, the Docker image, to be able to collect all the logs information. Who wants to see a demo? A live demo or just a recorded demo? A live demo, of course. I'm all about live demos. All right. All right, so automatic dashboards. So when you open up Cloudwatch services, what you're going to see is the automatic dashboards. Ultimately here, what you're going to see is all the services that you're using in your account. We've already worked closely with a lot of these services team to pre-build canned visualization, right? So understand what metrics are most important for these services to be able to summarize. You can set alarms on each one of these metrics. You can easily take any one of these automatic dashboards, these charts that we have, and add them to your own custom dashboards to be able to visually correlate all that data. So one of the things that we've added as part of this open preview is this new virtual service called Container Insights. Okay? So Container Insights is what's going to give you the observability needs that you have to be able to understand the health and the state of your container environment. So here you're going to see first launch into a multi-cluster view. So all the clusters in your environment, you're going to be able to see the performance of each one of these clusters. So we've already pre-calculated all the aggregations on your cluster, and we're able to see what's going on. At any point in time, you can click this, be able to see all the metrics, and be able to alarm on any metrics that you have in your environment. You can filter out the clusters that you have, and you can also see if there's something specific about a cluster that you want to be able to drill into more details. You're able to click on the action and be able to see all of the different logs collected from your container environment. So this is looking at application logs, your standard out, standard error logs. You can also deploy FluentD to be a sidecar container if you have other access logs or application logs you want to collect. You got performance logs, performance events. So we'll talk a little bit more about that. You have control plane logs, so as you may know or may not know, so we've launched EKS logging into Cloudwatch. So this will actually go into context directly for this watch demo performance cluster, and I can go look at my EKS logs, so that's scheduler, your API server logs, audit logs that you can all see within Cloudwatch logs. Your data plane logs looks at your kubelet and container runtime engine logs. And then your last one is, I can't even look, your host logs. So your host log looks at any kernel failures, right? So look at both at your kernel failure coming from your dmessage logs as well as your secure logs from that host. All right, so let's go into specific reports. So what we've done is we've pre-packaged certain reports to help you with the analysis that you need to do based on your nodes that make up your cluster, the services that are running within your cluster, the namespaces, and also the pods. That's typically what people want to be able to see, is see that granular data for any pods that are running in your environment. So let's start with the nodes. And what the nodes is going to do is going to show me all of the nodes that are running in my environment. And it's going to show me, let me do this, there you go. It's going to show me also all the pods that are running for each one of the nodes that are in this environment. And it's going to show it broken down based on the nodes and namespace, and I can easily sort this by the CPU and memory, and I can actually filter out the specific images that I'm running, or that I want to look for. At any point in time, you can change the time window. All of our metrics for that we're collecting is stored for 15 months. And is all usually done on something that's more long-lived, like a pod name or a host name. And these are some of the things that you can easily isolate in your environment and be able to further diagnose what's going on with this specific host, as an example. Simply hovering over a metric or a host that you have in your environment, you can easily see that correlation across all of the compute capacity that you have. So everything from CPU, memory, disk, network, and some of the other calculated metrics that we have, such as reserve compute capacity. So I like this metric in particular because the reserve compute capacity, it's typically a limit that's set on either your namespace or your pods or your containers. And in this case, this is a good metric that you can use to automatically scale up or down your cluster. So let me show you a quick example on how you can do that. So by clicking on View Metrics, I'll be able to see the metrics for these hosts that I have. But ultimately, what I want to do here is I don't really want to set this on a per host basis. I want to set this for my cluster. So what I'm going to do is I'm going to actually remove these metrics. I'm just going to go and look at these metrics available in my metrics UI. So what you'll see here is a new namespace that we've created, Container Insights. And you'll see different types of aggregations that we have based on the namespace, the service, the pod name, all the metrics that I've been showing you. So I'm going to go to the cluster name here. And what I'm going to do is I'm going to take that reserve capacity that I have. I'm just going to go ahead and add this in here just to show you what that looks like. And I'll go ahead and select all of them. And what I want to be able to do is I want to be able to create a policy that will automatically scale up my cluster or scale down my cluster if I don't have enough capacity in this environment. So first of all, note that every data point, every observation that we actually collect ordered statistics, right? So that means that anytime that you want to create a stats on these metrics, you can actually do percentiles, sums, sample counts. All of that information is available by default with any metrics that we collect with Container Insights. So let's go ahead and create an alarm. So what I want to do here is I want to simply let's give you an example of how easy this is. So if my cluster goes above 90%, ultimately what I want to do is it's a bit of a risk for me, right? It's one thing to say, I want to understand what's going on in my cluster, but at the same point, I don't want to prevent existing workloads from running in my cluster. So I want to automatically provision the necessary EC2 instances to be able to accommodate these additional workloads that are running in my cluster. So in this case, I'm going to go ahead and click Next. I don't need a notification. And what I'm going to do is I'm going to add an auto-scaling action. And as part of this auto-scaling action, I'm going to select the groups. In this case, this was a scaling action that policy that I've already created for this cluster. And I'm going to go ahead and select the policy that I want. So there's two policies here. So every time I hit the 90% number, what I want to do is I want to be able to provision 2 more instances in my cluster. And then the reverse is true, right? If I'm over-provisioning a cluster, the other thing that I want to do is remove instances from my cluster, right? And I have a separate policy to do that as well. But it goes to show you how important it is to be able to take that data, make sure that that's easy, be able to create an instance, and then ultimately I've optimized the way that my clusters work in my environment. And I'm going to go ahead and create that alarm, and now I've created a new alarm. Okay, so that was pretty simple. And I'm going to go back to my dashboard, and I'm going to go show you a couple more views and how we can further diagnose what's going on in our cluster. All right, so I showed you what we were able to do with the nodes view. Let's go into the pods view. I think everybody usually likes the pods view because it gives me the granular detail of all the pods that are running in my environment. So here, same thing, right? I get to see all the CPU compute capacity utilization by process, and I also get to see the usage over limits, right? So that's an interesting one because, again, a pod that runs over limits is not usually a good thing, right? Your orchestration engine can decide at any point in time based on memory pressures or CPU pressures to be able to evict that pod. So these are some of the things that you want to be able to account for and know in your environment so that you can take action, corrective actions to be able to prevent potential running pods that are asking for more resources that they don't have that may impact the service quality of this of the service that you're delivering. In this case here, I'm going to go and drill into my image service. And I'm going to go look at the different logs that we have and show you a little bit of some quick analytics that I can do with this service. I'm going to go ahead and click the application logs. And from the application logs, I want to show you, does anybody, by show of hands, who is aware or who has used CloudWatch Logs Insights? Oh, quite a bit less people. Okay. So this will be a treat. All right, so CloudWatch Logs Insight is something that was introduced in, or announced at reInvent. And ultimately what it is an advanced search capability on top of CloudWatch Logs. I know that everybody likes to write regex expression. That's what we used to have before. You don't have to do that anymore. We have a search language to be able to do that. So ultimately, you have commands, right, fields to be able to show different fields from your logs, the ability to filter your logs, be able to create stats on your logs, be able to sort, and then be able to create limits on the number of search results, and also be able to parse flat files. So if you have flat pieces of text, you can extract fields from that, and ultimately create all the same types of statistical queries that you want against that type of data. At the bottom here, what you have is all the discovered fields. So most of these application logs coming from Kubernetes environments, so standard out, standard error, are all JSON formatted. So we can automatically detect some of these queries of these types of search language. Same thing goes for Lambda, VPC Flow, CloudTrail, and we give you some examples of some of the queries you can use with these different types of environments that you have running in your account. All right, so let's show you what happens here. So if I run this query, so here you're going to get to see the image service. Again, contextually, time, I know the service that I was looking at. I get to look at all this great metadata for a specific service, the microservice that I'm looking at, and I get to see a lot of the data that I can see, the labels, the apps that I have. Easy for me to slice and dice, filter based on these types of the metadata that we're collecting in this environment. Some of the things that I typically like doing is certainly look at things like the logs for errors, right? So as easy as creating fields, log. I can do it by host or by container name. Actually, let's do container ID. And what I'll do here is I'll create another filter. And here what I want to do is I want to filter by a stream. So stream is typically 2 streams, standard error, standard out. So I'm just going to go and stream, look for all the errors, and go ahead and run this query. And here I get to see all the errors. The other thing that I usually typically do is I put the timestamp in there, sort by timestamp. These are all the types of queries you can do and easily save these queries into custom dashboards if you want. Generate reports, be able to easily extract this into ASCII or CSV format, and be able to share that with the rest of your team and your organization. Okay? So that's an example of how you can diagnose and see what's going on with your logs. The other thing too is you have the ability to do the same for traces, distributed traces in your environment. So who here in the room is familiar or uses AWS X-Ray? Not very many of you. Okay, so X-Ray gives you the ability to instrument any of the microservices that you have running in your environment to give you distributed traces visibility across all of your microservices. So ultimately, if you have X-Ray installed in your environment, you can actually go and drill into the time context of this trace by using AWS X-Ray. So when you click on X-Ray, you'll actually see all of the filtered traces for a given service, and you can debug that actual code a little bit more within your environment. So in this case here, I can go look at what's running the longest, click on a trace, and go see the distribution of this trace in this environment. You also have the ability to look at your service maps, be able to see the dependency of all these services to really help you try to understand how this microservices have been built and what is the dependency and potential errors that are impacting your services. And you have all kinds of great filtering capability that you can actually filter based on response time or errors that are impacting your microservices. All right, last but not least, performance events. So the performance events are all this high cardinality data that we're collecting for each one of these running containers, these nodes, these worker nodes that you have running in this environment. And this is all the metadata that we're also collecting, very similar to how Fluentd decorates the logs data. We do the same for that performance data. So if you run a query on that, you're actually going to be able to see all the decoration of that data. And you're able to filter out this type of data based on the different types of performance events that we're collecting. So you get to see the pod ID, the pod name, the container ID, some of the labels that you may want to slice and dice this data by, and the different types of nodes. So there's actually different types of performance events, right? There's container file system, there's node file systems, there's the nodes are the worker nodes, and there's also the containers. So let's go ahead and do a quick stats query against a container node. I'm just going to go do filter type equal container. And ultimately here, I'll get to see all of that information about that running container. I'll see the limits that were imposed, how much was requested, and several metrics that are available that you can actually query against and create stats against. You'll also see which instance ID it's running on, what type is it working on. Again, all that rich meta and state information that you want to be able to use to correlate to find out if you find isolated or systemic problems that are happening in your environment. So here I'll show you an example of how to query something like a page fault. Page fault's not something that you usually want to see in an environment. So let's go ahead and do a quick query on that. Stats. Let's do a percentile. Page fault. And let's do 90th percentile. And what I'll do is I'll split that by, we could do that by host name or by, we know it's already filtered by the image service. Let's do by host names, Kubernetes hosts. So ultimately what it's doing now is that based on where these instances of this image service is running, right, I can actually know if I'm seeing a different behavior of faults or errors, right, in this case, across my different hosts. And I'm seeing that common, right, that systemic issue. It's not isolated to one specific host. It's not isolated to one specific instance. I can do the same query. But these are the types of analytics that you want to be able to drive to help you understand that this is really a systemic problem. It's impacting this one image service. And now I got to go figure out with my developers, like, why is this causing all these page fault errors? Any point in time, as I mentioned, add this to a dashboard. And these dashboards, whether you're using one of our automatic dashboards that I was showing you for the pre-built visualizations, or you're using your custom metrics from any services that you want, you can go ahead and visualize any type of information, whether it's restarts, requested versus running queries, your node failures, and some of the last status of a running container as well. What was the last fault? What was the error that it actually generated? So there's a lot of information here that you can collect. This was only 2 of the reports. We also have the other 2 reports, the services reports, that breaks down what services are using that compute capacity and how can you isolate which services are using most capacity and how that's trending over time, right? As new features are being introduced, new capabilities are changed, ultimately, right, you may be demanding more compute capacity, so that means you need to provision more resources to accommodate this additional workload. And the same thing for namespaces as well, which continues to be a common ask by customers to be able to understand how are my specific line of businesses or my development teams using resources across my clusters so that I can better make sure that my clusters are properly provisioned. All right, so what do you guys think? Is this pretty neat? So again, very simple to set up. You got a few YAMLs to set up. Documentation is all there. I encourage you all to walk out of here and go try it out. Again, this is all open preview. It's not available in all regions. We probably have 8 or so regions where we are available in. If we are not supporting the region that you're looking for, please let us know. There may be some options for us to enable certain regions. In terms of key takeaways, the important thing is this is a fully managed service, right? You don't have to worry about setting up 1, 2, 3, 5, 10 different tools to be able to give you that full end-to-end experience. It can accommodate your needs based on the scaling needs that you have, whether you're just getting started or you're growing. And this is all done based on the right reliability and security practices that we pride ourselves on, right? Security is our #1 priority at AWS. Pre-built visualization help you summarize some of the key metrics that you need to be able to maintain a healthy, more reliable cluster, and ultimately give you that visibility also in context to the traces if you have AWS X-Ray in your environment. So please go check us out. Just do a search for Cloudwatch. Under Cloudwatch, you got Getting Started. It'll give you the access to our documentation. When you first install our agent, you'll have this new virtual service that'll come up, and you're able to use Cloudwatch. You'll look for also a blog post that's coming up later this week, where you'll be able to get more a walkthrough of some of the queries that you can use and some of the value you can use. You can actually get from Container Insights. And most importantly, if you are using ECS and Fargate, we're actually signing up customers now. So that should be available in the next couple of weeks to be able to get you going. So feel free to sign up for the beta program, and we're looking for more participants there to give us some feedback. So the same capability you saw here for EKS will be available for all of our container management services. All right, thank you so much for listening to the last presentation, and have a happy hour.
Yeah. All
right, guys, thank you.